on coastal carbon sequestration. We are thrilled to be joined by Beverly Johnson, Professor of Geology at Bates College, as well as Kristen Puryear, ecologist at the Maine Natural Areas Program of the Department of Agriculture, Conservation, and Forestry. Today, Beverly and Kristen are going to talk to us about how we can manage coastal ecosystems, such as salt marshes and eelgrass beds, to store carbon and help mitigate the drivers of climate change. Kristen is also going to talk about the Coastal and Marine Working Group of Maine's Climate Council and how they're incorporating this knowledge into their work. My name is Abby Bradford. I am the Outreach Manager for Maine Conservation Voters and Maine Conservation Alliance. My job is to make Mainers from across the state able to make their voice heard in the political process so that we can protect our common home and our future. MCV works to cultivate and use political power to help protect our environmental legacy, to pass pro-environmental laws, help elect pro-environmental candidates, and then hold our elected officials accountable without regard to political party. A few technical notes for today's event. You are all muted, but we do want to hear from you. So if you're having any technical difficulties, please message Will Sedlak through the chat function, which you can find by hovering your mouse over the bottom of your screen. We are also recording today's event, and we will share a link to that recording with you all after it's over later this afternoon. Today, we will first hear from Beverly, and then Kristen will speak, and then they will both answer all of your questions. So as questions occur to you, please send them to me, Abby, through the chat function. I'll keep track of the questions, and then I will ask Beverly and Kristen to ask. At the end, we will wrap up. I'll let you know how you can take action to help promote climate smart land management practices here in Maine. And then I'll also announce our next lunch and learn. Thanks so much, everyone, for joining us, and I will hand it over to Beverly now.
Great. Thank you, Abby, and thank you all for joining us today. Wish I could see you in person, but not going to happen today, so maybe in the near future. So I'm delighted to be here. I really sincerely appreciate the invitation. What I'm going to talk about is basically a fairly general presentation on opportunities for coastal carbon sequestration in Maine, highlighting the science of it. And the thing that's very exciting for me about this opportunity to speak is that this work, this science actually informs some of the policy and that is under consideration or being built, or recommendations that are actually being put forward at the state level. So it's just a really neat mix of science and policy, I think. I want to highlight the collaborators on this larger project, which is part of the Maine Climate Council work. Kristen Puryear is going to be talking, as well as Claire Enterline and Angela Brewer, Nicole Price, and then Curtis Boland as well. And then also a shout out to the people I work with at Bates who make the data that you're going to see here shortly possible. That's Phil Dostie, as well as many Bates students, and then lots of others. Okay, so the actual focus here is to consider the Maine Climate Council challenge put forward earlier this year, and that is by 2030, by the year 2030, we need to have a 45% reduction in greenhouse gas emissions, and that's relative to 1990 levels. And so you can do that by reducing the amount of carbon that gets released into the atmosphere wisely. And you can also do that by increasing the amount of carbon that gets taken up by the biosphere, which is what we're going to talk about today. So the outline for this talk, I'm going to talk to you a little bit, I'm going to talk to you about coastal carbon in Maine, give some definition about sequestration, and specifically the 3 ecosystems along the coast that are relevant to this problem, so salt marshes, eelgrass beds, and seaweeds. And then I'm going to give you an example of a coastal carbon project where we might actually imagine optimizing sequestration in under a certain setting so that we're improving the amount of CO2 that's actually getting sequestered annually. We'll talk a little bit about our restoration of the tides, and then I've got some conclusions and recommendations. Just highlighting too that my background is almost entirely in salt marsh carbon cycling, at least with regards to this project. I've done a little bit of work with students and colleagues in eelgrass beds and absolutely nothing in seaweed. So that's my caveat there. Okay, so when we think about CO2 reductions, removing CO2 from the atmosphere, I'm certain you've heard this term geoengineering, and that is basically to use our vast knowledge about the geology of the planet and engineering and mechanically remove CO2 from the atmosphere. And some of the very exciting ideas coming out around this have to do with what's called basalt carbon capture. And so that is concentrating carbon dioxide from the atmosphere, injecting it into the subsurface where it can react with water and a certain type of rock to actually create a mineral that includes carbon. So it converts CO2 gas into a mineral. So that's very exciting. Lots of work is going on with that. You know, other sort of more typical or more traditional ways of thinking about geoengineering and CO2 reductions include CO2 deep well injection. And so that is concentrating CO2, carbon dioxide, injecting it into the deep subsurface where it's isolated by the geology that's, it's impermeable, so it can't come back out. So that's again, exciting stuff. But there's something I think even more applicable certainly to the state of Maine, and that is a term that my colleague Nathan McTeague, who's currently at UT Austin, coined as biogeochemical engineering. So instead of just geoengineering, we think about the biology, the geology, and the chemistry, and we use this in natural systems. We optimize it in natural systems, and so the idea is you have carbon dioxide in the atmosphere with water. You turn on the plants, so you basically photosynthesize in the presence of sunlight, and you convert this CO2 into organic carbon. So plant parts, leaves, trunks, roots and rhizomes. And if you can get a significant amount of that plant underground via burial, then you actually potentially have a mechanism for removing a lot of carbon from the atmosphere. And it turns out that coastal ecosystems are particularly effective at burying carbon. So in Maine, we have salt marshes and eelgrass beds, as I've said, but mangroves in the tropics and subtropics are very important for carbon burial. And more recently, this idea that seaweeds, so intertidal, subtidal seaweeds actually export carbon into the sediment so that it gets buried. So lots of potential here in Maine. Just an image of a salt marsh in Phippsburg. These grasses, Spartina grasses, are producing a tremendous amount of carbon that is going into their roots and rhizomes, as well as their above ground biomass. Eelgrass beds from Mount Desert Island here. So these are underwater for most of the time. People aren't too tuned into them, but they are incredibly productive systems, meaning moving a lot of carbon from the atmosphere into the biomass, the above ground biomass, but mostly into their roots and rhizomes. And then probably something everybody else is a little more familiar with are seaweeds. So this is a rockweed study going on by, I think, Nicole Price. She sent me the slide this morning. So again, I refer questions to Nicole Price on seaweeds. Okay, so blue carbon in Maine. Blue carbon is a term that has gotten a lot of play recently, and it's been almost 10 years now since it was coined. It basically refers to, at this point, salt marshes and eelgrass beds. And what you're looking at in these ecosystems is a very high soil carbon content associated with them. And the reason why the carbon content is so high is that about 85 to 95% of the plant is actually built underground. in the roots and rhizomes. And because these systems are intertidal, they're fully saturated, they're always wet, more or less, and there's very little oxygen that can diffuse into the soils. And so the decomposition rates, the rate at which this organic matter breaks down, are very, very slow. Another really great thing about salt marshes and eelgrass beds is, again, they're at this interface between land and sea, and they experience the tides. The plants themselves, actually, the above ground blades and leaves, trap sediment in the water column. And so the actual plants, with time, build their own platform or their own substrate. So they continue to grow up and through the sediments that they trap. So you get these massive, with time, you get massive amounts of carbon stores. Okay, so this is, these are some data from a compilation, a global compilation from 2011. And the unit down here is grams of carbon per meter squared. So you can think about a meter squared as being maybe like the half of the size of your dining room table. Okay, so a meter in one direction, creating a square, and a meter is about 3 feet. So, and then grams of carbon is just a mass of carbon. And so what we're looking at here are annual carbon burial rates. So this is the amount of carbon that gets buried, sequestered in different ecosystems. So the upland forests here are given to boreal, tropical, and temperate, and then the coastal blue carbon ecosystems. And so what you can see here is mangrove, salt marshes, and seagrasses, the lower two bars being relevant to Maine. These sequestration rates are actually an order of magnitude greater than what you see in the upland forest. So they're very, very effective at pulling carbon out of the atmosphere and storing it. The estimated global area here, so this is what you can see, this is just an area, kilometer squared. So many more kilometers squared on the planet is actually occupied by upland forests relative to coastal blue carbon. So carbon more effectively sequestered in salt marshes and seagrass beds and mangroves, but occupy a smaller area on the planet. And when you combine those two terms together, what you get is an amount of carbon that is buried per year. So this is teragrams of carbon. It's 1 million metric tons of carbon that's buried annually. And if you add all this up, it turns out globally that coastal blue carbon sequesters between 20 and 25% of the global carbon that is buried across the planet. So 25%. So it's shocking, really, how effective these systems are at reducing carbon from the atmosphere. So in Maine, we can do some fun calculations, and we've made some measurements. Some of the maps that are very preliminary, Kristen and Claire and Angie are working on more accurate maps, but these are just what you can find online, basically, these areas. So in salt marshes, there's approximately 73 kilometers squared in Maine that is salt marsh, and about 128 kilometers squared that is eelgrass beds that are tied up in eelgrass beds. And we've made some measurements with students through the years, and so we have lots of data on carbon stocks and carbon sequestration from sediment cores that are collected from the salt marshes. We also have some sense of greenhouse gas emissions. This is an image of a student collecting air on the salt marsh and actually taking it back to measure it for methane concentrations. So there's field methods, there's lab methods, and there's mapping that has to be done. And you can do mapping either, mostly that's done by aerial surveys, so satellite imagery, drones, things like that. So there's a lot of methods that go into this. And what we've come up with is just an image. This is one of my favorite images of cutaway of salt marsh in Scarborough, the Scarborough salt marsh, excuse me. And this is a buried tree stump. I just love this whole thing, but tons of carbon in this system. And what we know is from just these back of the envelope calculations, so just estimates, that the carbon burial rates by salt marshes and seagrass beds really is only about, let me back up for a second. So based on the measurements we've made and the data we've compiled from many, many marshes, and from some preliminary seagrass beds, from just a handful of seagrass beds. We know that the total amount of carbon that's buried every year is approximately somewhere between 1% and 6% of the total that is buried by the state. So 1% to 6% of the total. So it's not the 25% that you see globally, right? It's about 1% to 6% that you see in the state. And of course, the rest of the carbon that's buried by the state every year, most of that's taken up by the forests. So the upland forests in the state are actually doing the lion's share of the work here. But what's critical to recognize is that the salt marshes and eelgrass beds only occupy less than 0.1% of the land surface in Maine. So the total amount of carbon that's being taken down in the state is dominated by the forest. But if you compare a meter squared area of forests and salt marshes and eelgrass beds, the salt marshes and eelgrass beds are much more efficient at sequestering carbon. So it argues for the importance of these ecosystems and optimizing their ability to actually sequester carbon. Okay, so I said potential in that last slide because it turns out I don't think we're fully optimized right now yet. So this is a schematic of a carbon and greenhouse gas reservoirs and fluxes in blue carbon ecosystems. And so basically, each one of these blue blocks is a reservoir of carbon. So we have the atmosphere, we have plants, and we have soils. And then the gas exchange is up here as well, carbon dioxide, methane, and nitrous oxide. And when you have a system that's fully functional, carbon dioxide is taken up by the plants in a salt marsh and eelgrass as well, and shunted almost all of it into the soils. As I said, 85 to 95% of the carbon goes into the soils. And the dark arrows represent the movement of carbon in a healthy ecosystem. You also have, I should say, you've got carbon coming into these systems from rivers and terrestrial bodies of water, terrestrial inputs. And then you have carbon going in and out with the tides and marine. So there's definitely carbon in and out from both sides. And okay. So, and then also, a healthy plant system will also respire. So they will release some CO2 into the atmosphere. But the net movement of carbon when you've got one of these coastal ecosystems is into the plants and into the soils. So there are times when salt marshes especially become sources of methane and sources of nitrous oxide. So these are also greenhouse gases, much more powerful, much more effective at trapping heat from the planet's surface as it tries to escape the planet. So very, very effective greenhouse gases. And you can, as I said, you can get these greenhouse gases coming out of the marshes when the marshes are not healthy. So it's important to keep track of all of this stuff. So what alters the carbon sequestration in salt marshes? Now I'm going to really focus in on salt marshes. Tidal restrictions do. They often actually result in the release of greenhouse gases. Excess nutrients also alter the carbon sequestration potential. Shoreline development. Sea level rise is kind of a big unknown. I think Kristen's going to talk a little bit about that. Coastal squeeze, and then eutrophication and invasives also can create massive problems in the carbon cycling within a marsh, or the carbon in versus the carbon out of a salt marsh and the eelgrass beds. So I'm going to zoom in on tidal restrictions because this is something that we have control over. These are things we can actually remove to optimize our carbon uptake by salt marshes. So, okay, tidal restrictions basically are structures that are in place and are associated with, in place to actually promote the crossing of people over salt marshes and tidal creeks. And so they can look like culverts that are trying to connect the tides as a road goes across the salt marsh, rock walls. You can get old passings. This is just a very old passing, maybe 100 years old on this marsh out in Harpswell. You can also have levees, artificial levees that are pooling up fresh water on the upstream side of the marsh, and also preventing the tides from coming in and out. So tidal restrictions basically reduce the ebb and flow of the tides in and out of a salt marsh. And yes, can really change the carbon cycling in a marsh, turning it from a carbon sink, or carbon going into the sediments, to a carbon source where carbon is getting emitted. So here's the thing though. You saw the variation in what tidal restrictions can look like, and those are just a couple of them in the state. So the point is that one size does not fit all. So the marsh carbon budgets actually vary on a marsh, and so this is a marsh we studied with Cascade Bay Estuary Partnership and Harpswell. This part of the marsh is sequestering carbon effectively. Over here where you've got Typha growing, this part of the marsh is actually releasing methane. So you can get variability within a marsh, across a region. It's all very exciting. There's a lot of really fun things to be thinking about. Okay, so the idea is to basically identify what are called coastal carbon projects. And a project is an action that results in the reduction of greenhouse gas emissions. So make a change to something so that you're reducing greenhouse gas emissions. So you can restore and conserve or protect tidal salt marshes. You can restore and conserve, protect eelgrass beds. You can grow and bury kelp, for example. So, and there are various ways to actually protect and conserve and restore. I'm gonna just focus this on removal of a tidal restriction. I'm gonna give you an example of a coastal carbon project here. And keep in mind too, these carbon projects will push us towards the main Climate Council goals, as well as mitigate climate change by reducing, again, greenhouse gas emissions in the atmosphere. So the first thing you need to do when you're trying to identify a project is to establish baseline conditions. You've got to understand how much carbon is actually being either emitted or sequestered in the system you're looking at, as well as carbon stocks. So that is a lot of fun, good work to be done. Okay, so this is just a very simple example to show you how we might be thinking into the future of about carbon projects. Super simple. So this is the Sprague River Marsh in Phippsburg, and you can see it here, very elongate marsh with a tidal creek, the Sprague Creek in the middle of it. And the idea is to go into a section of the marsh where we have ditch plugs currently sitting, and then remove them. So ditch plugs and then remove them to restore tidal flow. So a little bit of some satellite imagery here for you. So, and I'll explain what a ditch plug is. So this is, again, that northern part of that marsh. This is a satellite image that's very grainy from 1996, but it shows the marsh before a ditch plug went in. And so this is all very healthy salt marsh grasses with ditches cut into the surface of the marsh. And the ditches have been in place for a very long time. It's practice that has been done for centuries on salt marshes to remove the surface water, the natural pools on salt marshes, and to reduce mosquito breeding habitat, basically. So early 2000s, the U.S. Fish and Wildlife Service wanted to restore pool habitat on the marsh surface, so they employed a method of restoration called ditch plugging. And so the idea is, I'm going to show you the next slide. So what they did was, this is 2002, they installed some ditch plugs on 3 ditches to, again, create some pool habitat, to bring some pool surface back onto the salt marsh. And so you rip up peat, and you plug the ditches, and you use some plywood to create basically a dam. So this is 2002, and in 2010, so same projection here, just different years. You can see the ditch plugs with the arrows. What you can see is this is very effective at building water on the surface of the actual salt marsh. And so, you know, the idea of building pool habitat by installing ditch plugs is a good one if you are interested in fish. So, but you can see what happens when you replace a marsh platform, those healthy grasses, with water, is that you reduce the amount of CO2 that actually gets sequestered, right? Because you no longer have those plants that are moving carbon dioxide from the atmosphere into the soils. And so you can calculate the amount of carbon that is actually no longer being sequestered by using those numbers that we looked at earlier and establishing baseline conditions. So what we know is that this much of the marsh is about 15,000 square meters, and it is currently bare. There's no sequestration going on, very little anyway, although there is some evidence that suggests that some of these pools are actually moving carbon into the subsurface. But generally speaking, there's, you've reduced the amount of CO2 sequestration there. The restoration then would be to open up these ditch plugs, make sure that the salt marsh platform maintains its elevation such that salt marsh grasses can grow back there again. And so to do that restoration, you can imagine basically that you would increase the amount of carbon that's sequestered annually up to 2.3 plus or minus 0.9 megagrams of carbon. So simple removal of the tidal restriction allows the salt marsh grasses to grow very well, again, as long as the elevation of the marsh platform is maintained, and then turns the carbon direction movement into the soils again. Okay, so just to conclude, I would say there's great potential for restoration of marshes and eelgrass beds in Maine. And in this, we'll be able to reduce their greenhouse gas emissions and increase the climate mitigation benefits. We know from the Tidal Restriction Atlas, the great work there that's being done, that there are approximately 900 tidal restrictions currently in the state. And if we can identify and prioritize systems with the highest potential for climate mitigation and ecosystem benefits for restoration, we can contribute to the goals of the Maine Climate Council, as well as restore our wonderful salt marsh ecosystems and eelgrass beds as well. But there's continued research is definitely needed. As I said, the carbon cycling in marsh is not always consistent. We know it varies with the hydrology, the pore water salinity, the strength of the marsh platform, all sorts of things. You can get variable carbon emissions from year to year. And there's a lot of really fun and excellent work to be done in eelgrass beds that I think is just hopefully about to take off. So that's all I've got right now, and I'll turn it over to Kristen. Thank you. Kristen, you good?
Yep, I think okay. I got it up. Is it up?
Stop sharing and put it in present mode and then share again.
Okay. How's that?
Looks great.
Okay, great. Thanks. Okay, thanks for that, Bev. That was awesome, and just shows how much good work is going on in the marshes. So, hi, I'm Kristen Puryear. I'm an ecologist with the Maine Natural Areas Program. As Abby introduced, MNAP is part of the Department of Agriculture, Conservation, and Forestry. And we're the state's natural heritage program, for those that aren't familiar with us, which we have our core mission is to map and track Maine's rare plants and rare and exemplary natural communities statewide, including salt marshes, and then share that information for conservation and restoration and management planning. As a group, we've done extensive work mapping tidal marshes in Maine, documenting condition, coming up with different methods and metrics for doing that work, identifying opportunities for restoration, and also for marsh migration that is a result of sea level rise. So it's exciting to be a part of this work group and also with this blue carbon conversation. I'm going to give you a quick outline of what I'll be talking about. First, I'll just go into sort of the background and framework of the Coastal and Marine Work Group, and then move on to talking about what mitigation and adaptation are in the context of the work group and the Maine Climate Council, and use that as sort of the segue into talking about how the information about blue carbon and the idea of blue carbon as a mitigation strategy is being advanced, and then give you some examples of what that looks like in the strategy, but also tying into some of the research and science and projects and all this momentum that's going on that make this exciting work and actually pretty cross-cutting and integrated for the Climate Council work. Okay, so as I think most of you know, last year Governor Mills signed into law LD 1679, which created the Maine Climate Council. And as part of that law, the Climate Council and its various work groups will create a climate action plan by the end of this year. And then it will get updated every 4 years. The plan is to include mitigation and adaptation strategies to meet the greenhouse gas emission reduction targets, which are set at 45% reduction in Maine greenhouse gas emissions by 2030, and then 80% by 2050 relative to the 1990 levels. And this is being led by the Governor's Office of Policy, Innovation, and the Future, also known as GOPIF. And I thank that office for use of these slides, which you'll see scattered throughout my talk. Okay, so the Climate Council's 39 members. They're appointed by the governor and also by legislative leadership. And they, as I said, will work to approve the strategies that will be included in the climate action plan based on recommendations from the work groups. There's 6 work groups. You can see them in this graphic here, as well as a science and technical subcommittee. And our job in the work groups is to come up with these strategies and then build consensus on which ones will be moving forward, and then get them ready to submit to the Climate Council in June. So in the short time that I have here, I'm going to cut right away to the work of the Coastal and Marine work group, but you should be aware if you're interested in more information or in meetings or any of the evolving products of these other work groups, it's all publicly available on GOPIF's website, which you can see at the bottom of the slide here. And I'll show this link again at the end of the talk if you aren't writing fast enough. So within the Coastal and Marine work group, we have 5 subcommittees that are broken out by major topics. As you can see here, it includes ports, marine transport, and working waterfronts. There's ocean renewable energy, fisheries and aquaculture, and then ecosystem conservation and restoration, and a monitoring subcommittee. And the blue carbon strategy, the blue carbon work, is essentially all coming out of the 2 subcommittees circled there, monitoring and then ecosystem conservation and restoration. And I think that'll make sense once you hear more about it. So each of these subcommittees is developing strategies as well. I don't have time to go into all of them, but at this point it looks to be that probably 6 or 7 strategies will be completed and brought forward to the by the Coastal Marine Work Group to the Maine Climate Council. So each of them are identifying different mitigation or adaptation actions, and then we're each tasked with considering multiple pieces of information, such as current science and policy in Maine related to the strategy, examples from other states or regions, what are the knowledge gaps, and thinking about some of the socioeconomic costs and benefits. And so these are all elements that are being fleshed out within each strategy. And as I move into the next part of the talk to talk about the blue carbon strategy itself, I just want to point out that just to have this sort of as the background way of thinking, that of course this work around blue carbon can be advanced through policy. That might be sort of like the default thinking with information that's being delivered to the Climate Council or to legislators. But there's also a lot of potential here for these strategies and actions to be addressed through natural resource management and conservation and restoration and various incentives. So there's multiple tools that can be used here that are both voluntary and regulatory. And so hopefully there'll be some way that blue carbon or topics that address blue carbon and carbon sequestration will be adapted into new or revised policies. But I think it's important not to lose sight of the whole myriad of opportunities really for practitioners and landowners and researchers and even municipalities to do something that can actually make a net difference. So here's a glimpse of the strategy. It's not very exciting to look at, but and you don't have to read it all, but just to prove that there is something there, and you can read the whole thing if you'd like to, again, by going on to the GoPIF website. But I just wanted to bring this up to note to flag the two words at the very top in the header there, which are mitigation and adaptation. So blue carbon optimization, which is the title we've given to this strategy, is one of the mitigation opportunities that will be forwarded to the Climate Council. And as a mitigation strategy, it's one of the inputs that can help with the state meet its greenhouse gas reduction goals while meeting some of the other targets that are listed here. And again, these are sort of the parameters that we as work groups are supposed to be addressing for mitigation strategies. So obviously it's not a strategy that involves turning off engines or making things more efficient, but what makes this mitigation stand out and be different is that than some of the others that might be put forward is that it leverages nature and ecosystems. It's a type of nature-based solution that promotes the ability of coastal and marine systems to sequester and store blue carbon and even increase that sequestration and storage through ecosystem restoration, as Bev has already talked about. As it turns out, it's this nature-based mitigation strategy is also really good for adaptation. So the way we're thinking about adaptation here is to anticipate the adverse effects of climate change and act to prevent or minimize harm or take advantage of opportunities. And also to consider how the adaptations can foster the value of the state's natural resources and natural resource industries and their ability to support resilience. And then other things to consider are improving the resiliency of Maine's communities and protect people's welfare in dealing with the impacts of climate change, and also building upon all the good work that's already being done out there. Great work and great resources and great ideas. The take home here is that by leveraging our natural resources, we're harnessing a whole suite of benefits, collectively known as ecosystem services, which I think Bev mentioned at the end of her talk. Which the tidal marshes and eelgrass beds and seaweeds are all providing, and that frankly will become increasingly more important as biodiversity is at risk, as coastal storm events become more frequent or larger, as fisheries experience different climate-related stresses, etc. So in this blue carbon strategy, mitigation allows for adaptation here in anticipating the changes and impacts, helping to minimize them, and promoting resilience and human communities, resilience within human communities, and resilience for biodiversity. It seems like a heavy lift for one strategy, and there are a lot of pieces, but I'll break it down a little bit now so you can start to get a sense of what it entails. So here's one example I'll show you, and then I'll go through I think it's 3 different examples, and then I'll show you how they roll up into the strategy overall. So in this first example, as Bev has highlighted, removing tidal barriers that degrade downstream tidal systems can help improve those baselines. So can help make that difference between, or flip the switch between a marsh being a source of methane and being a sink for carbon. The Maine Coastal Program, as she mentioned, has done a preliminary analysis and found that there's over 900 potential barriers to tidal flow These are the bad culverts and road crossings, and these are impacting tidal marshes, as you can see in this picture here. In addition, many of our marshes are degraded in some way because of historic impacts like the ditching, then ditch plugging, and also levees and berms and things that were put in place a couple of 100 years ago. So this blue carbon strategy states that upgrading crossings and restoring salt marshes should be pursued, that there should be more of a collaborative and organized programmatic effort towards achieving this, and that it should be accompanied by a baseline documentation of carbon storage and greenhouse gas emissions to track that mitigation benefit of restoration. Another example here, this is with respect to conservation. So the Maine Natural Areas Program has documented about 22,000 acres of tidal marsh across the state. The majority of this is salt marsh. And we've also worked with the Maine Geological Survey to chart potential for marsh migration under various sea level rise scenarios from 1 to 6 feet. And done some other modeling to get a sense for what the potential opportunities for marsh migration are across the state, and where Conservation and Restoration Act actions will help to protect those opportunities. So basically the idea behind this is that if tidal marshes, as sea level rises, tidal marshes can either keep up by growing vertically through sediment accretion, and if they can't keep up, they need to be moving inland in order to persist. And Maine potentially could lose significant proportions of its salt marsh under really any sea level rise scenario, but in particular as it gets up into the 3 foot or 1 meter range. So protecting that space for marsh migration is critical. Right now, our mapping shows that just over a quarter of the area needed to accommodate marsh migration under a potential 1 meter sea level rise is actually protected. So there's a lot of work that still can be done to secure land and secure opportunities for marshes to move in response to sea level rise. And I brought this example up because it's a concept that focuses on how voluntary practices could help support the future resilience of marshes and their ability to store carbon even as sea levels rise. So a final example here, this is somebody doing an eelgrass survey, scuba diving and doing their eelgrass survey from the Department of Environmental Protection. So this example is just brought up to identify one element of the strategy that discusses promoting the protection and potential restoration of eelgrass beds statewide. So another big source, another big carbon storage opportunity. The Department of Environmental Protection and the Department of Marine Resources are currently working to update baseline mapping of eelgrass beds across the state. And that will allow the state to begin to monitor changes and also viability for restoration. But as you probably know, there's been significant die-offs that have been documented over the years due to factors such as green crab invasions, water quality issues from runoff, and also physical impacts to shorelines. So better documentation and improved action towards reducing those threats and allowing restoration where it is viable or feasible are all promoted in this strategy as a way to better protect and even increase coastal and marine carbon stores within seagrasses. So, so on the surface of it, this strategy is considered a mitigation strategy, but I can't emphasize enough that this is also what's good for carbon of these in these coastal and marine ecosystems is also good for human communities and biodiversity alike, and that there's countless win-win scenarios for each action that prop it up as a pretty great adaptation strategy as well because of those tremendous ecosystem services. So as the examples that I cited earlier, they they roll up into these higher level categories of action that are summarized on the left-hand side of the slide. These include conservation of tidal marshes, including identifying and protecting those that are able to adapt to sea level rise and the space for marsh migration, conserving eelgrass beds, and conserving macroalgae or seaweed. These all keep that carbon in place and then keep that sequestration action going. But perhaps the visible or more tangible outcomes of those actions are the things like it also protects rare species habitat, recreation opportunities, protects resources that are so valuable for commercial and recreational fisheries, buffering from coastal acidification, protection from storm surges and wave action. The list kind of goes on, and sort of somewhat portrayed by the images on the right there. The second key component to the strategy is restoration. Restoration of these habitats types that are degraded or that have declined because of human or climate related impacts are the focus here. So restoration would actually help take some of these habitat types that are contributing greenhouse gases like the methane from a degraded salt marsh, or help to make these habitats more resilient, where right now they have a very tenuous ability to perform that carbon sequestration and storage role because of impacts. And once again, through restoration and allowing these natural systems to perform their ecosystem services such as habitat and water quality protection, et cetera, once they're back into function again. The third high level category of action in this strategy is targeted monitoring of our blue carbon stores to get a better catalog and a better baseline of what these systems are doing now and what they're capable of. Maine DEP, DMR, Maine Natural Areas Program, Maine Geological Survey, and researchers like Bev and Bigelow Lab and multiple others are doing all this excellent work, either on broad or regional or even very local scales, but finding a way to do something that's a little bit more cohesive, that enables us to measure the carbon stores more systematically across the state and in these different systems, and doing a more comprehensive assessment to track the benefits is also something that we cite as being needed. So I'm going to wrap it up here by quoting the strategy itself. This is a picture off the coast in Freeport that was taken as part of the eelgrass survey. So you can see those big eelgrass beds sort of diagonally through your slide. Blue carbon optimization focuses on the ability of healthy coastal and marine areas to provide vital benefits to the community, economy, and of course, ecosystems, while performing long-term carbon storage and sequestration of greenhouse gases and ameliorating coastal acidification. So this is another slide that just shows you ways that you can engage with the process and the content that's being put together. There will be public listening sessions that will be held in the coming months. The format, of course, will be different than was originally envisioned. Some kind of web-based listening sessions, I think, but definitely stay tuned for where and when and what those will be all about. And thank you. And also thank you to the suite of people listed down here that have been contributing all their research and information and revisions to this strategy as it's developed.
Awesome. Thank you so much, Kristen. We will move into the Q&A now. The first question comes to us from Linda, and she asks, is more CO2 released by the energy sources that are used to inject CO2 into the deep subsurface than is sequestered through that process? And Kristen and Beverly, feel free to jump in.
Well, that's a great question. I honestly don't have the answer to it. I'm not, I just haven't really studied that very carefully. I do know there are problems with sort of guaranteeing that that carbon dioxide is actually isolated for the long term, because things can move up through the geology or fractures, and also you can have, yeah. So yeah, I will stop there before I get myself in trouble.
Sounds good. Two folks asked two related questions. The first was, inundation seems to be eroding local marsh grass in wells. What can we do to reverse this? And then another question was, what happens to the trapped carbon in marsh as it erodes with the higher tides we're getting?
Yeah, so the inundation is one of the big problems, right? And big questions is how to hold off sea level rise. And it's definitely happening. So that's currently one of the big questions that people are trying to figure out. I will say that when you erode the edges of the marshes, that carbon that is, stored in the peat, sometimes thousands of years old, gets exposed to the atmosphere and oxygenated waters, and it actually undergoes respiration, that it gets converted back into carbon dioxide. There's also some studies on the burrowing habits of this invasive crab that goes into the peat, into the subsurface, and basically injects oxygen that way into the subsurface. And so you get increased erosion rates and release of carbon dioxide from the green crabs as well. So, but yeah, good question. Definitely, you don't want this happening. You need to keep the carbon sequestered in the actual peat and the sediments for it to, be an effective sink.
And I'll just add to that. The Pete Slavinsky from the Maine Geological Survey looked at some records of the frequency of flooding up on the higher parts of the marsh. So basically the number of hours of where floodwaters reach a higher high water level, and seeing how that's changed over time. So this gives you a sense of how much water is getting way up into the marsh and how often it's flooding that upper part of the marsh, which is not what it's used to. And then what he found was, this is definitely all boiled down, but over the past 10 years, that frequency of flooding has increased from about 350 hourly readings per year to over 500, 530, something like that, hourly readings per year. So it's not your imagination that you'd be seeing more water up on the high marsh. It's something that's been documented in water level readings as well.
Great. We've had two more questions that two folks have asked, so we'll do those two and then wrap up because we only have a few minutes. The first is, are you combining green crab trapping with eelgrass planting? And someone else asked what's being done generally and what's being planned to prevent the further spread of green crabs and the damage they're doing to eelgrass beds.
I know I can only say minimal amounts about this, unfortunately, in terms of the eelgrass. The green crabs have certainly spread and have been documented to cause a lot of damage. They have also seemed to go through some sort of boom and bust cycles. I don't know that people have come up with any terrific ways of managing them or avoiding them invading into new areas. I know people have talked about trying to harvest them and maybe cull the pressure in that way. And in terms of restoration of eelgrass, I think it's a pretty tricky science. Not all places are practical or have the right set of conditions that make eelgrass restoration appropriate. And so that's a lot of what others that are definitely more in the know are studying.
Great, thank you. The next set of questions that are related are, do you see a role for the LMF bonds to invest in saltwater marshes in land bordering rich tidal areas? And someone else had asked, what are some strategies generally to protect wetland buffers for marsh migration, especially if it's private?
Yeah, certainly. I think there's a role for any conservation funding source to be thinking about this and how it meets with their own priorities in terms of climate change resiliency and adaptation. And I know it's something that LMF is entertaining how to incorporate that into their planning. In terms of protecting marsh migration opportunities, a lot of the land trusts are working on this. Maine Coast Heritage Trust has really taken the lead on incorporating marsh migration zones and opportunities that really present themselves as some of the top tier in the state into their own strategic planning. And and that's also perforated through a lot of the smaller coastal land trusts as well. So it's on people's radar, which is great. And anytime that a land conservation project, addresses conservation of the marsh and some part of the buffer, and maybe extends all the way up to some road or interior forest area, the suite of benefits that come along with that really build, on top of just thinking about marshes and marsh migration. So again, it's a win-win package.
All right, we only have 3 minutes left, so I'm going to end the Q&A there, but please feel free to reach out to me or Beverly or Kristen with further questions. Sharing my screen. So Kristen talked pretty in depth about Maine's Climate Council and specifically the Coastal and Marine Working Group. I just wanted to quickly mention that MCV is serving on several of the other working groups of the Climate Council, and along with our partners across the state, we're using those roles to try and make Mainers' voices heard in the process. So in addition to the ways you can take action that Kristen shared, we'll keep you all updated with further opportunities to get involved. And you can take action right now by signing MCV's petition to the Climate Council calling for a strong climate action plan. And I'll have Will send that through the chat right now. And it will also be included in an email that you'll all receive after this event, which will also include a recording of this webinar, which a few of you have asked about. You can view it again later. I know that there's a lot of great content in there to absorb. We are also right now calling on people to take another impactful action, which I will let Will Sudlack tell you all about.
Hi, everybody. Our other big action, and this is both for Mainers and non-Mainers alike, is the best thing you can do right now for the environment, of course, is to vote. And what we're looking to have you all do today is to pledge to vote absentee. We're trying to lower the loads on the polling places as much as possible. We want to keep in-person voting open for those that need it, but recognizing that many of us don't need that option. And so in the chat going right now is a absentee pledge. We're asking you to sign that and then request your absentee ballot. This is going to allow the town clerks and the Secretary of State's office to appropriately plan for our July 14th primary. So request and pledge today. It's really an impactful thing that you can do to help keep our democracy strong here in Maine.
Thanks, Will. Thank you all so much for attending. Thanks to Beverly and Kristen for speaking. As I mentioned, you'll all receive an email after this. That will also include a brief survey. We want to know what you think, so please take a few moments to give us some feedback. And if you enjoyed this, I hope that you join us for our future Lunch and Learns. We're hosting them every Friday from 12 to 1 on Zoom. If you are not on MCV's email list and you'd like to be alerted about future Lunch and Learns, you can sign up on our homepage, which is also going to be sent through the chat, and that's maineconservation.org, and you can find the sign up on the bottom left. Thank you all so much again. Have a great rest of your day. Take care.